We're looking at the next little thing. So before we learned how to balance equations using the half reaction method in acidic solutions. Alright, and how that works is, the first thing you have to do is you have to determine the oxidation numbers, right? The second thing that you needed to do is you need to figure out what is being oxidized and reduced, right? After you do that, you need to write out the half reactions. And when you do this, there's no electrons involved, right? The fourth thing that you needed to do there is you need to balance the atoms, right? How we do that, balance the atoms beside O and H. The fifth thing we looked at is, how do we do that? So once I balance the other atoms, I need to balance O and H, right? So in order to balance that, I need to add H2O to balance the O, right? And then I need to add H plus ions to balance the H, right? After that's done, I need to balance the charges. So we need to balance the charges, and how we do that is we add electrons, right? Once that's done, the next step you need to do is you need to multiply the half reactions, right, to make the number of electrons of both half reactions must be equal. Right, the next thing you needed to do is you need to add the half reactions, right, and then we cancel out the, say, things that appear on both sides. And then the last part is you need to do a final check. Right, to make sure everything is balanced. That means the atoms and the overall charge of the reactants and the products. Right, and that's how we do a situation where I'm going to balance the equations using the half reaction method in acidic solutions. So these are just the steps that we're going to be taking now. What happens next is, when I'm looking at something like this, I need to do two types of things. The first thing is to balance in an acidic solution. And the next thing I have to do is I need to learn how to balance in a basic solution. So with the basic solution, we're going to get probably up to here. And then from there, from step 9, we're going to add on more. So I know it's quite hectic and it's quite intense, but what you need to understand, or what you need to take back from this, is that it's not something that you just memorize, right? You need to be able to solve a variety of problems. And when we solve a variety of problems, and we've seen like what we did in class now, is that the more problems you solve, the more comfortable you get with it. So at first, yes, it seems like it's a lot and it seems quite overwhelming, but after a while, we can get a little bit comfortable. So let's have a look at what happens when I want to use this half reaction method, but I want to use a basic solution. Right, what we're looking at is how to balance redox equations using the half reaction method in a basic solution. And what we're looking at is, let's say I had something like this, and this is a redox reaction. I've got Zn plus NO3 1 minus gives me Zn2 plus NO2. This reaction that I'm seeing above here is unbalanced. And if it's unbalanced, it needs to be balanced. And how we're going to balance that is we're going to get into a basic solution, right? And when we do that, we're going to end up here at the second equation. And what you would have noticed about the second equation is that I've now got this H2O, sorry, on this side. On the other side, I've got OH minus hydroxide. So how do I go from here to here, right? Now, in terms of the method, it will indicate to you whether it's an acidic solution or basic solution. There will be no surprise. So no one's going to be like, balance this, and then you must decide, oh no, acidic or basic. And then after you've done all of the work for both, then hopefully you get marks. So when we talk about excuse me, when we talk about a basic solution, we must recognize that we are looking at, if I'm looking at the word basic, I'm looking at adding on OH minus, or rather hydroxide ions, right, to balance these equations. Because if I add more of OH minus, the solution is becoming more basic, right? So we must recognize that this is what we're doing. In the other one, we added H plus ions, again more acidic. Now these processes involved in basic solutions is similar to the process for balancing in acidic solutions, except the process for basic solution have a few more extra steps at the end. So we're going to get up to step 9, and then from step 9 we're going to go a little bit further, and we're going to get that balanced equation. So let's start with some of the things that we talked about previously about the steps that we're looking at. So let's see. So let's say they said to you, they want you to balance this equation in a basic solution. So you've got Zn plus NO3 minus is going to give you Zn2 plus NO2. Right, with that, the first thing you need to do is assign oxidation numbers. With the zinc, I know it's going to be 0. With the NO3, I know it's going to be minus 2 times by 3, which is going to give me negative 6. But I want a 1 minus charge, so I've got here plus 5. Then with my zinc here, I've got plus 2, because I've got a 2 plus charge. The NO2 is minus 2. There's 2 of them, so minus 4. Then the nitrogen has to be plus 4. So that's how I'm going to assign those numbers, just like we've been doing this whole time. All right, if I link up the zinc and the zinc, what I'll notice here is that it went from 0 to 2. So in this situation, the oxidation number was increased. Therefore, I have oxidation. All right. The other one, if I link up the let's say I link up the oxygens, notice it started at negative 2, at minus 2 and minus 2, which means there was no changes. All right. And then the last one that I have here is I've got the nitrogen, and I link it to the other nitrogen, and I'll notice that the oxidation number went from 5 to 4, which means my oxidation number went downwards. Therefore, I've got reduction. All right, once I've made that sort of decision, I need to make a statement, and I can say that, therefore, the zinc or the Zn or the zinc was oxidized, and the NO3 minus nitrate ion was reduced. Right. After I'm done with that, the next thing I need, so I've done step 1, I've done step 2, I need to do step 3, which is the half reactions. Right, so if I look at the half reactions, right. Now I just want to write out the half reactions, but I don't need the electron. So basically Zn went from Zn to Zn2 plus, and that's my oxidation reaction. And my reduction reaction was the NO3 minus became NO2. Nice and simple. Right, so I'm done with that. The next thing I need to do is I need to balance. I'm just going to move this a little bit up. I need to balance the atoms. All right, so these are the other atoms. All right, so remember, when we do this, we're always going to start with the reduction half reaction. All right, always, 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 always. So the reduction half reaction is NO3 minus, which is going to give me NO2. If I'm looking at my nitrogens and oxygens on both sides, I'll know that my nitrogens are 1, oxygen here, 3, oxygen there, 2. Because my nitrogens are already balanced, I can move on to the next thing. The next thing says that I need to add in H2O so that I can balance the O, and I need to add in H plus ions to balance the H. So I'm going to go and do that little step next. All right, so I must look at the side that is more oxygen deficient. So in this situation, my right hand side is more oxygen deficient. So I've got the same situation. I've got the NO3 minus and I've got the NO2, and I'm going to add to this side H2O. Right, now what this does for me is, remember I still got N and O here, I still got N and O, but now I've created a situation where, this is 3 and 2, I've added in water. So now I've got an H on the side. By getting that H, I've got 2 hydrogens, and oxygens have gone up to 3. No? Yes, 3. All right, so what I've got to do now is, what's going to happen here is, I need to sort out, so I did that. I sorted out that. Now I've got to add in the hydrogens. We've done this before. So on the other side, I've got to come here and I've got to put in H plus ions. Now it must be balanced. So I've got to put in 2 H plus. Right, just a note down here, and I think you should just take this down, is that adding H plus ions makes it more acidic, right? And we're going to have to sort that out, because we don't want it to be more acidic. We actually want it to be more basic. So at some point, we're going to have to sort those H plus ions out. So you can already see that if it says basic, I'm already having a problem. So I need to make sure that I can fix that. Right, so I've sorted that out. So now I can see that my nitrogens balance, don't forget that becomes 2. Nitrogens balance, oxygens balance, hydrogens balance. So the atoms are all balanced. And after the atoms are balanced, I need to balance the charges. So now we're going to balance, charges. And how do we balance charges? We must add electrons. Okay, let's have a look at that. So now, if I had to sort this out, I'm left with 2H plus plus NO3 minus gives me NO2 plus H2O. Right, let's check charges. Over here I've got 1 plus and 2 of them. Over here I've got -1 because it's an ion. Over here I've got 0, and on the other side I've got 0 as well. So my overall charge on this side is equal to +1. Right, on the other side, because I've got 2 plus 2 and -1, and on the other side I've got an overall charge of 0. Alright, so now I need to balance the situation out. So I need to add electrons to whichever side needs to be balanced out. Now I can't minus, right? I have to add electrons. So what I would do is I need to get rid of this +1. So the best thing to do is to get rid of the +1, I need to add in here. Oops. I need to add in there 1 electron. Alright. Now what that would do for me is it would give me -1 plus +2 plus -1. And that's going to give me an overall charge of 0, which kind of aligns with my other side, which is also equal to 0. So now I know that the charges are balanced. Yay, that's not so bad. Alright, once that's done, let's look at the oxidation side. So I'm done with the reduction side. I've sorted out my situation. I need to sort out the other side, which is oxidation. So let's just move this up here, and let's have a look at oxidation. Just going to choose a different color here. Right, oxidation. Right, let's have a look here. Alright, now what's going to happen here in this situation, I must look at my equation, which is the Zn, which is going to give me Zn, and I'm going to end up with Zn2 plus. Right, now sidebar for this one, the first thing here I should notice is that there are a couple of things. First, I must balance other atoms. Right, then I need to add H2O to balance the O's, and I need to add H plus to balance the H's. Right, if I check here, I've got Zn, sorry, and I've got Zn. I've got 1 of each of them. Right, so in terms of balancing other atoms, it's fine. Notice on both sides that I don't have oxygen and I don't have hydrogen, so that these 2 steps here become null. The reason I write them down is because sometimes they aren't null, and then you're going to have problems. So make sure that for oxidation, you're doing the same thing that you did for reduction. So now that you've checked the balancing of the atoms, that's great. You need to check the charges. Let's just pan this out. Move this word here. Right, if we check the charges for this type of thing, for zinc here you have 0, but for Zn2 plus you have +2. Now you need to sort that out. I need to get rid of that +2. I need to make sure that the charges are the same on both sides. So I need to add in electrons. So what we're going to do is we're going to add in electrons over here. I'm going to add in 2 electrons. So what that does is it says this is +2 plus -2, and the overall charge is 0, and the overall charge here is 0. And by looking at that, it means my charges are now balanced by adding in 2 electrons on the right hand side. Right, the second thing that needs to happen here is that I need to write down my 2 reactions, and I need to make sure that it kind of evens out in terms of electrons. I need to know that those electrons are all the same charge. So let's have a look. So I've got my oxidation reaction, which is Zn, which gives me Zn2 plus 2 electrons. And my other one for reduction is an electron plus 2 hydrogens, H plus ions, plus NO3 minus gives me NO2 plus H2O. Right. That's my two equations, oxidation and reduction. What we've got to do now is I need to make sure that the numbers of the electrons are the same. So can you see here I've got 2 electrons, but over here I've only got 1 electron. So I need these two equations to be the same. So to get this one, I can't divide. So what I've got to do is I've got to multiply. So I'm going to take this equation here and we're going to multiply by a factor to balance the electron number. Right, so the number is times 2. Right, so let's write that down and let's have a look at what I'm going to be looking at then. Alright, so now what I'm looking at for this zinc one, for this reduction one, is I've got 2 electrons plus 4H plus ions plus 2 NO3 minus gives me 2 NO2 plus 2 H2O. So now that is sorted out, and they've got, if I have a look here now, I can see that I've got 2 electrons there, and when I come down here, I've got 2 electrons here. So once that's sorted out, I need to add the reactions. Alright, let's add them up. And by now we've had quite a bit of practice in doing these, so it's not like you're being asked to do something foreign. So I'm going to put all the reactants on one side and all the products on the other side, and then I'm going to cancel out. So I've got Zn plus 2 electrons gives me plus 4H plus ions plus 2 NO3 minus gives me Zn2 plus 2 electrons plus 2 NO2 plus 2 H2O. And in this whole thing, I can cancel out those 2 electrons. So therefore, at the end, my final balanced equation is Zn plus 4H plus 2 NO3. Please make sure you write these things down. Don't just leave it like, yeah, I canceled it out. It goes like that. No. Make sure that your marker understands that you have written out a final statement plus 2H2O. Right, at this point, this is where we're going to start with the basic solution. So the first goal of this thing is to get up to step 9 of the acidic. And once you get to step 9 of the acidic, you can start moving forward. So if our goal was to balance this in an acidic solution, then at this point here, I would have reached that goal. But here's the problem. They didn't ask me to do it in an acidic solution. They asked me to do it in a basic solution. And if I look here on this side, can you see that? I have H plus ions, which makes this a solution an acidic solution. And that's not what we're looking for. So the instructions say that it needs to be a basic solution, so we have to go through a few more steps to get rid of those H plus ions and replace them with OH minus ions. So I'm going to take these and they're going to be replaced with OH minus ions or hydroxide ions, which will make the solution, I'm going to go up here, basic. All right, so let's start with this basic equation. Right, the next step here, which would be step 10. So going from step 10. Right. For step 10, for each H plus ion, add one OH minus to both sides. Right? So let's have a look at what I'm doing now. So now I've got Zn plus 4H plus 2NO3 minus gives me Zn2 plus 2NO, I think it was NO2. Oops, there was a mistake. Can I fix that? 2NO2, sorry, 2NO2 plus 2H2O. Right. So what we must add now is hydroxide ions. So if I'm looking here, there's 4. There's 4H plus. So I must add 4OH minus to both sides. So over here I'm going to say 4OH minus, and here I'm going to say 4OH minus. So I've added that to both sides. Right. So that's the first part of 10. Right. Then step 11. You can even, step 11. Let's say step 11. Right. What happens in step 11 is that we must combine the H plus and OH minus to make water. On one side, because it only exists on one side. Right, so if I look at the side that's involved now, it's this side over here, the side of the reactant. So have a look here. On this side here, right, I've got 4OH minus and 4H plus. But on the other side, I've got 4OH but no H plus. So what's going to happen is these two are going to come down here, and they are going to combine to make water. Alright, so now what am I left with? I've got a situation where I've got 4OH minus. So this is all happening on the left hand side, eh? 4OH minus plus 4H plus ions is going to give me 4H2O. Now this must be added to the equation. And this here must be eliminated. Because what's actually happened is these two here, this business over here, has become that. So now we must rewrite our equation out. So now I'm left with, let's write this out. Zn plus 4H2O, there we go, added it in, plus 2NO3 minus is going to give me Zn2 plus 2NO2, just going to move this here, plus 2NO2 plus 2H2O plus 4OH minus. And that's what my equation is currently looking like. Alright, so notice that on this right hand side, nothing happens. Alright, so because I didn't have any, so make a note here, there are no H plus ions. So H2O cannot be formed. And I said that before. Alright, the next thing that has to happen is step number, what are we, 12. Right, in step number 12, we must subtract H2O from both sides if possible. Because remember, if there's the same thing on both sides of an equation, we can eliminate them. So I want you to think about it like this. If I had 2x minus 1 is equal to 15 plus 2x. If I take this 2x over here, it's going to cancel that. If I take it on this 2x onto the other side, it's going to cancel. So what can happen is I can actually just eliminate that. Same concept here. Think of it as a maths problem or maths equation. Right. So when I'm looking at this situation, I'm just going to copy and paste this. Bring it down here. Right. When I'm looking at this situation here, I need to subtract the waters, isn't it? So if I look here on this side, I've got 4H2O. And on the other side, I've got 2H2O. So I've got to do a little bit of a subtraction between these two. So all I'm going to say is 4 minus 2, which leaves me with 2. So on this side of the equation, here, on the left-hand side, I'm going to be left with 2H2O. And on this side here, on the right-hand side, I'm going to be left with no H2O. It's going to be 0. Because basically the 4 from the left-hand side cancelled out the 2. So that's not going to even exist anymore. Right, so I've got 0 on this side. And I've got 2H2O on the other side. All right, the next step that we look at is we're going to look at step, let's see here, step number 13. All right, step 13, we want you to write a final balanced equation where the atoms are balanced and the charges are also balanced. All right, so let's write that out. Now I got rid of the water. I'm now left with Zn plus 2H2O. Right, can we see that from the previous thing? Plus 2NO3 minus gives me Zn2 plus 2NO2 plus 4OH minus. Alright, so you've got Zn, I've got H, I've got O, I've got N. So I'm doing a final balance of my atoms. Zn, H, O, N. So my zincs on each side, I can see I've got 1 on each side, so that's fine. My hydrogens, I've got 4 on the left, 4 on the right, that's fine. Oxygens, on the one side I've got 8. And the other side I've got 8, so that balances. And my nitrogens, I've got 2 on both sides. 2 on both sides, and that balance. So the atoms, sorted. The next thing you need to check is the charges. So when I look at the charges, like I did in the previous one, let's do it in another color. Right, the zinc is 0. The H2O is 0. The NO3 minus is minus 1, and there's 2 of them. So the overall charge on this side is equal to negative 2. On the other side, my Zn2 plus, I've got plus 2. My NO2, I've got 0. And my OH minus, I've got minus 1. And I've got 4 of them. So positive 2 plus minus 4 is equal to minus 2. So I can see that my charges also balance. So my final answer then is that. There we go. And that is how you balance using the half reaction method in a basic solution. And then we'll do some examples and stuff so that we can get through to it. So just remember, when we do these types of equations, or we're looking at balancing, we need to make sure we get right here to the bottom. I must get to the final equation for an acidic solution. Right? Once I get there, I can do steps 10, step 11. So I've got 10 here, I've got step 11 there, I've got step 12 over there, and then I can come and finish up with step 13. So please remember, with the basic solution, there are a few steps that are left over. So you've got number 1 to 9 of the acidic, and then you've got step number 10, which is for each H plus, add 1 OH minus to both sides. Step 11, we had to combine the H plus and OH minus to make H2O. All right, sometimes it could be on both sides or one side, and then that's fine. Then once you've got your H2Os on both sides, which you do kind of end up with, you can do step 12, which is to subtract the H2Os from both sides. Right, and that's a bit of a mathematical move. That's if possible, right? And then the last step, step 13. Just going to move up here. You need to make sure that you balance atoms and you balance charges, and you have a correct final balanced equation. Right, and that's your rules for how to balance what's this thing? How to use the half reaction method to balance equations in a basic solution.